Welcome back, ladies and gentlemen. Today we're talking about constructing a probability distribution. So we're going to kind of end before Algebra 2 hits on this idea, but there's an idea that goes across that there's a pretty standard form of distribution that's going to be interesting. It's going to mimic what we're able to make in tables, and you'll go into that in Algebra 2. It covers a lot of rules. For example, as a teacher, there are some students who are going to like me, there are some students who are going to dislike me. Doesn't matter what I do, they're going to exist in both categories. And then the majority of students are going to be just meh, in between. I mean, I don't have bad feelings, I don't have good feelings, it's just I was in his class. And that's a statistics thing. It always happens. Every time a speaker talks, there's going to be people who are like, yeah, this is worth my time. There's going to be people in the exact same presentation who are going, this is a waste of my time. And most people are in the middle of going, okay, well, it didn't waste my time, didn't contribute a lot. I'm happy with it, or I'm not happy with it, but I'm not upset about it, or I'm not ecstatic about it. Okay. Now, on this particular one, we've got 2 die, and we're going to be rolling them. So we're trying to figure out what's going to be the probability of earning a sum on the die. Now remember, this guy right here, way back when, showed us that there were 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So there are 36 total possibilities in finding the sum of 2 die when they are rolled. Anywhere from 1, 1 to 6, 6, and everything in between. All right, that's where I got a lot of information. So I just wanted to bring that to your attention, where I got mostly this 36, because that 36 is actually used across the board here. The way that this works is there's only one way to roll a 2. That's a 1 and a 1. You can't roll anything else to get a sum of 2. So there was one possibility of an outcome out of 36. That was this whole thing. Well, to roll a 3, you can either roll a 1 and a 2, or you can roll a 2 and a 1. So there are 2 possibilities. Oh, wrong one, highlighter. There are 2 possible ways to roll a 3. Well, 2 out of 36 simplifies to 1 out of 18. There are 3 possibilities of rolling a 4. You can roll a 1 and a 3 and a 1, a 2 and a 2, and a 2 and a 2. A 2 and a 2, a 1 and a 3, and a 3 and a 1. There we go. So 3 out of 36 simplifies to 1 over 12. Then you have 4, possibility of 5, and so on. And I'm not going to go over all of them, but that's where all these numbers come from. Then we kind of peak here at 7. And all right, so what I'm going to do is I'm going to go back and start graphing this. A 1 out of 36 chance at rolling a 2 means we're right here. A 1 out of 18 chance of rolling a 3 means we're right there. A 1 out of 12 chance means we're right there. A little bit taller, but you get the idea. There we go. All right. Then we have, for rolling a sum of 6, or sorry, a sum of 5, there is a 1 in 9 chance. For rolling a sum of 6, there is a 5 in 36 chance, which is right here. Now I've got to change this to color code. Here's the magic one. At 7, we kind of hit a peak. We make it all the way up to a 1 in 6 chance. And here's what's interesting. If we go backwards, or as we increase, it's almost like we're going backwards, because to roll an 8 is the same probability or chance, or sorry, a sum of 8, as rolling a sum of 6. A sum of 9 is the same probability or chance as rolling a sum of 5. A sum of 10 is the same probability as rolling a sum of 4. Oop, wrong way, there we go. And sum of 11 is the same as sum of 3. And rolling a sum of 12 is the same as rolling a sum of 2, because the only way to get a 12 is to roll a 6 and a 6. There is no other way. So there's only a 1 out of 36 chance. So what we notice, hopefully, is we increase until a high point, and then all of a sudden we decrease at an equal but opposite rate. That right there is going to be a very important type of distribution. So make sure you're paying attention in Algebra 2, because it's really good to be able to think about a normal distribution.